Previously, we've looked at functions, and we've created one function for each task that we're going to perform. However, in C++, we can do something called function overload. What this means is that we can create different functions with the same name that's going to give us an ability to take in different parameters, parameter types, and even different return types. Let's take a look at some examples of this. I'm going to create a function that's going to return an int called add and have two variables that'll be passed into it. Now I've created my function prototype, I can create my function. Now, for a simple function like this, I'm just going to add these two values together. Obviously, with something as simple as add, I would probably just use the addition symbol, but we're just trying to show the technique here. So I'm going to specify return x plus y. Now, the question is, what happens if I don't want to use integers? I want to use something like a double. Well, I can come in and say double, add, double x, double y. Specify my return type when I write my function. And I'll create my function here. Once again, I'm going to return x plus y. Now, you might ask, why would I want to do that? There's a couple reasons. Number one, my x and y in my first function is an integer. If I just had it as a double, then it would take my integers, convert them to doubles, and return it as a double, which means that I would either need to A, typecast it back down to an integer later on, or B, I'd have to deal with potential inaccuracies in the process of converting from an integer to a double, because doubles are approximations, and I might not get that exact value. So this allows me to get a more accurate value based upon what I'm using. And it doesn't matter what I have, this two function will work. C++ will look at my parameters as they're being passed in, and then it will choose the best function for it to use. Now, important thing to note, my return type cannot be used to differentiate which one of my functions will be used. That is strictly up to my parameters and the order that they're found. So my parameters in any type of overloading function should always be in either a different type and or different type order. There are instances where a function cannot be chosen based upon the information that's picked. So we need to make sure we're very clear on our data types as we're trying to pass things in, not allowing things to potentially be selected inappropriately. Therefore, we want to keep track of our data types. Now, in both these cases, they will work very well and very similarly. However, let's add in one more example just real quick so I can kind of show you what could happen if I want a different number of parameters. And this is a pretty common thing too. You can create a new function prototype. And write my function. In this case, if I only pass in a single value, I'm just going to return that value plus itself. Let's take an example of how we're going to run this. Now I have some sample data to run. When I go to run this, I get each of my values as I would expect them to show up. So Each function got called based upon what information was sent. Even though the same function name was used in all three cases, C++ was able to figure out which function ought to be called and then go and call that function so that we could reuse a name. This is very good for when we need to abstract our function calls without having to worry about what data necessarily is being passed in. I don't have to have 4 or 5 very similarly named functions. Instead, I can use the same function name and just pass in different data to get the right result based upon what I'm looking for.